Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration using the trapezium rule. This is part 14, and I encourage you to check out our previous videos on the integration series. That is from part 1 to part 13. Remember to subscribe so that you don't miss out on any of our future uploads. We are still working on the integration series, and afterwards we'll move on to other topics. Diving into today's business, recall, for y is equal to f of x, graphing it in the way that we have it in this graph, we can find the area of A, which is the shaded part under the curve y is equal to f of x. Remember how we did it in the previous videos? So the area A will be given by the integration from a to b of f of x dx. However, the area may not be computed due to 1. The limitations on previously covered integration techniques, and 2. The integration of some functions f of x may be impractical. In such cases, the trapezium rule can be implemented. Right, let's take a look at what the trapezium rule is all about. The trapezium rule is a numerical technique, meaning that it approximates the area. Now, moving on to the implementation of this trapezium rule. The total area A can be split into n trapezium strips, each of width h, and that h is given to be b minus a over n. Recall, the a is the lower limit, the b is the upper limit, the n is the number of strips or the trapezia. Recall, trapezia is the plural of trapezium. And the h is given by b minus a over n. Now, taking a look at the graph that we have here, our h is positioned over there. Now, we also have what we refer to as the ordinates or the vertical edges. Now, y0, y1 up until yn. These are the sides or the edges. Or just yi, where our I is between 0 and n. And in this case, we are taking all the natural numbers, including 0. So as we look at the graph here, we note that the first ordinate, which is y0, is equal to f of a, and yn, the last ordinate, is equal to f of b. Then the sum of all the trapezium areas will be given by a is equal to h over 2, and in brackets y0 plus yn plus 2 times y1, y2 up until yn minus 1. This occurs because we've got, say for example, 5 trapezia. So if we get the area of each and every trapezia, recall from the formula of finding the area of a trapezium, we are going to get h over 2, which is meant to be the height, times the sum of the sides, a and b. That is for finding the area of one trapezium. Now we add all of the trapezia. What we get is the ordinates that are in between the first and the last, that is to say from y1 to y4. These will be repeated twice. That's why we have the 2 there, and the first and the last are only used once. Therefore, we make use of that particular formula. That is the formula that we'll be referring to from time to time in finding the area using the trapezium rule. Right, so prior to problem solving, note the following. Let's consider the facts on the trapezium ruler. The first thing has to do with the accuracy. So the accuracy of the approximation is improved by increasing the number of strips or the trapezia. However, this results in a reduced trapezia width, h, implying that we are going to have an increased number of computations involved in calculating the answer. So we have to decide whether we are going to improve the accuracy or just finding a balance that will give us a moderately accurate approximation with less computations. The second thing is the number of strips or intervals or trapezia is 1 less than the number of ordinates. From the example that we spoke about, if you decide to have, say, 5 strips, then it means that you're going to have 6 ordinates because the first is y0 and the last ordinate is y5. So if we count those would be 1 more than the strips that we have. The third thing is the trapezium rule either overestimates for a concave curve or underestimates for a convex curve. So now let's look at the two graphs that we have over here. So the first one is a concave curve, highlighting the blue area on the graph, just above the graph over here. That is what we would use as our trapezium rule because we are connecting the sides, the other end here. So that gap over here results in an overestimate. So imagine having multiple overestimates of this nature, in as much as they might be small, but the cumulative contribution would be an overestimate, a huge overestimate sometimes. Now, looking at the convex curve, we would have underestimates because when we connect the other sides here, we leave out the small gaps. And if we sum up all the small gaps that are left out, we may end up having an underestimate of what the area is supposed to be. And that is what we were referring to. Let's take a look at example 1. The diagram shows part of the curve y is equals to e to the x over 2x. Now, taking a look at the graph that we have this graph and we are focusing on the area starting from x is equals to 1 to x is equals to 3. And we can see that this one here is a concave curve, implying that we are going to obviously have an overestimate from what we looked at. That's one thing to take note of. Then we have the question as use the trapezium rule with 4 intervals to estimate the area of the shaded region, giving your answer correct to 2 decimal places. Awesome. And then state with the reason whether the trapezium rule gives an underestimate or an overestimate of the true value of the shaded area. Great. Now, the solution. If we have 4 intervals, it means that we are going to have 4 strips and 5 ordinates. And also, our h, the width of each trapezia, is going to be given by b minus a over n. And of course, we know what our b is, a is, and n is. We simply substitute 3 minus 1 over 4 so that we get the width of 0.5. Great. Now, we are going to compute for y0. So y0 will be given by f of 1 because 1 is our starting point or the lower limit, which was a. So 1, where we have x, we just substitute with the 1 so that we compute it in that way. For y1, you would have the same thing, but this becoming f of 1.5. Why are we saying so? It's because the width is 0.5, the starting point is a 1, we add the width or the 0.5, we get 1.5. So we substitute where we have x, we have that 1.5. This implies that for our y2, we are going to add a 0.5 to our y1 value or the x1 value so that we have f of 2. So where we have x in the function, we just substitute with the 2. Then for y3, we add also 0.5 to the previous x so that we get 2.5. F of 2.5 to be precise is equals to e to the 2.5 over 2 times 2.5. Then for the last one, y4, we add 0.5 to the previous x value of 2.5 so that we get 3. That is to say y4 is equals to f of 3, giving us e to the 3 over 2 times 3. Now, computing those, we are going to get the values in the table here, where we have x ranging from 1 to 3 and yi from 1.359 to 3.348. And of course, recall, our I is from 0 to 4. And that is what we would get here for the yi's. Now, with that, we are going to use the trapezium rule formula that we talked about and highlighted before. So in this case, we are going to have that, and we substitute for the h, for the ordinates as well, from y0 to yn, so that we get to that particular stage over here. And take note, the question had said to 2 decimal places, but because we're still computing and we still want to keep our answers as accurate as possible, there is no harm in keeping 3 decimal places in the computations. But remember, the final answer has to be to 2 decimal places. If not, you might be penalized for not doing that. So we are going to have our answer here as 4.07 square units. That is our answer. And going to the other part that was talking about whether the trapezium rule overestimates or underestimate. Remember, by the nature of the curve that we were given, that was a concave. The trapezium rule in this case overestimates, because remember, when we join the edges or the other sides there, we are going to have some gaps that overlap, that are above the graph. So as a result, it overestimates. Let's jump into example 2. The question says, the diagram shows part of the curve y is equals to 2 minus x squared, natural log of x plus 1, and the graph is given on the right. We can see that our a, which is the lower limit here, is from 0 up until 1, which is our upper limit, or the b. And we are asked to find the area using the trapezium rule with 4 intervals to estimate the area of the shaded region, giving our answer to 2 decimal places. And of course, we have the last bit of the question. State with the reason whether the trapezium rule gives an underestimate or an overestimate of the true value of the shaded area. Now, this one is more or less like a convex curve. So as a result, it is going to underestimate, because when we connect the other sides of the trapezium or trapezia, we are going to leave out some small gaps that are below the curve, implying that we are going to have a value that is lower than the actual area. So it's good to know that before we even start answering the question. Jumping into the solution then. So we have 4 intervals, meaning that we have 4 strips, and that results in 5 ordinates, where we have our h given by that formula, and substituting 1 minus 0 over 4 would give us h of 0.25. So remember, we are finding the ordinates. So y0 will be given by f of a, and in this case a is 0. So where we have x, we substitute with the 0 like that into the particular function that we are given. We move on to y1. Remember, our h is 0.25. That is more like our step size. So we are saying that to the previous x value, we add the step size of h, which is 0.25, so that we have f of 0.25. So where we have x in the function, we just substitute it with the 0.25. We do the same thing for y2. So adding a 0.25 to the previous x, we would get a 0.5. So f of 0.5, we would have it in that manner. y3, adding the 0.25 to the previous x value, we get 0.75. We substitute into the function up until we get to y4, the last ordinate or the last edge. So we have y4, and adding 0.25 to the previous x value of 0.75, we get 1. So f of 1 would be that here. In computing this, we are going to come up with a table of this nature where we have the x values from 0 to 1, taking a step size of 0.25. And the yi's will be given by what we have computed here. So the first one is a 2 up until we get to 1.307. And recall, the I is from 0 to 4 in this particular question. Why? Because we were asked to use 4 strips or 4 trapezia. Now, we know the formula for finding the area using the trapezium rule. We simply substitute the values with the appropriate value that we obtained and calculated before. So with that, we are going to have that. And remember, the question asked us to find the answer to 2 decimal places. But in computing, we can use more decimals. The final answer is the one that precisely has to be to 2 decimal places, because the whole idea is to keep our answers as accurate as possible. So the final answer we get is 1.81 square units. And also on the other part of finding if the trapezium rule overestimates or underestimates, we are saying that since the curve is a convex, the trapezium rule underestimates. Congratulations if you have made it thus far. I'll leave you with the following task. Make sure to write in the comment section how you solved this problem, or even how you managed to go about some problems that you encountered. Remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Thank you so much for watching Numbers Simplified. God loves you.